Hello, AP Calculus AB. Welcome to day 83, Finding Extrema Practice. We're in the middle of our Topic 6, Applications of Integration and Differential Equations. Today is more on the applications of integration. I know I promised you that most of these applications would be word problems, and that's not the case for today. But I wasn't quite sure where to fit this in, and it's such an important topic because it almost always comes up on the free response questions these days. That it's worth having a day just to work through these. So, what are we going to do today? Well, we're going to look at an extremely common free response question type, FRQ question type, that's somewhat redundant, where you're going to be given the graph of f prime of x, or some version of that, and then you're going to be given one value on f of x, such as f of 2 equals 3. And then you're going to be asked to find other values on f of x. And we've touched on this actually very recently when we did particle motion. The key is going to be manipulating that fundamental theorem of calculus. So as a reminder, we did this before where this was capital F, where this was lowercase f of x and then these were capital F's. Well, I thought today we could look at it from a slightly different perspective and think about this as the antiderivative of f prime, and that gives us lowercase f of b minus lowercase f of a. If you were asked to isolate f of b, right, then we would have to get rid of this guy, and that would give us f of b equals f of a added onto the integral from a to b of f prime of x dx. And if we wanted to look at it slightly differently and isolate f of a, the easiest way I like to think about it is adding it to this side and then moving the integral over to the other side, which will give us f of a equals f of b minus the integral from a to b of f prime of x dx. Now, how do you know which one to do? Well, ultimately it doesn't matter. If I were given f of 2, then 2 is going to take the place of either a or b. And it doesn't matter which one. I tend to prefer to put this 2 on the smaller side of things. So let's say that's f of 2, and then you're also asked to find f of 4. Then we'd go from 2 to 4. However, if this was like f of 1, and this was f of 2, then I'd put 2 on the top and 1 on the bottom part, right? Just going from least to greatest. And again, you don't have to do it that way, but that's just how I've found I tend to do these problems. So let's look at a few of these. I have 2 free response questions prepared for you that we're going to run through today, and then you'll have a few to try on your own. The first one comes from 2017, and it gives us a few things. Function f is differentiable. That means when you take the derivative is defined everywhere, or there's a slope everywhere. And you can actually see that because they give you the graph of f prime over here. And remember, the graph of f prime is showing you the values of every slope of f, right? For example, if we're thinking about, I should have done a different color here, if we're thinking about the function f, and I wanted to know what's the slope of f at -6, then we'd go to the graph of f prime. We'd say, oh, the slope on f at -6 is 2. So there's an up 2 over 1 instantaneous rate of change on the original graph of f. They also tell us that there's a point on f that we know. We know f of -2 equals 7. That will come in handy shortly. Lastly, we're given that the graph of f prime, which is of course down here, consists of a semicircle and 3 line segments. And that's important in case, hypothetically, we had to find the area of this shape, and we wouldn't want to say, oh, I think that's a semicircle, but maybe it's the graph of sine. Well, now we know it's actually a semicircle, which makes finding the area a little easier. Okay, what do we do? Well, they're asking us to find the values of f of -6 and f of 5. Okay, well, let's just tackle one at a time. How do I know which one to do first? Normally, I found that the first one is easier and the second one is harder, so I tend to start with that first one. But let's go ahead and look at the point that they give us, f of -2. All right, we can move or find area in 2 different ways from here. We can add up area moving to the right, and that's going to include a semicircle and a triangle, or we can add up area moving to the left, which is just a triangle. All right, we're looking for 2 x values, one at -6 and another one at 5. So the question becomes, would you rather find this area first, or would you rather find this area first? And I'm going to tackle the easier one, the triangle. Okay, so let's go ahead and set this up. We always start with an integral. Okay, and integral-wise, we're going to go from the least, -6, to the greatest, which is -2, and then we are going to measure the area of f prime. Now, how do I know to do that? Well, they're giving us values of f, and how do we get from f prime to f? We use, of course, an integral. So we're going to go from f prime of x dx, and know that the antiderivative of that is going to be f of something minus f of something. What things? Well, it's f of the upper limit minus f of the lower limit. Out of these 1, 2, 3 terms, which one are we interested in? Oh yeah, we want f of -6. So let's go ahead and isolate that. We're going to add f of -6 to the left, and simultaneously we're going to keep f of -2 where it is, but we're going to subtract the integral to the other side. And now we have a formula to find f of -6. We just need to do this math. So as I continue through, f of -2, I'm realizing now I'm probably going to run out of room, so maybe we'll split this and pretend that's going to be enough room on the other side, and I'll just write very small. F of -6 equals f of -2, which is given to us, that is 7, minus, and then this integral. So we're going from -6 to -2. Now notice, if you go from least to greatest, that takes us on the left and moves to the right, which is the way we want to accumulate area. If you had written this backwards, you would have had to change the sign. It all ends up getting the same answer. You just would have gone about it a different way. So area-wise, let's go ahead and think about this friendly little area here. It looks just like a triangle, has a base of 1, 2, 3, 4, and a height of, they tell us it's 2. It's nice. So we're going to find the area of the triangle by doing 1/2 times the base times the height. Okay, finishing this off, 7 minus, that's 8, half of 8 is 4, so it looks like f of -6 is 3. Cool. Let's do the other, f of 5. Now, you should probably have a good idea of how to do this at this point, so if you want to pause me and work through a little quicker, never a bad thing. But if you didn't pause me, let's see what we can do here. So we're going to work with this guy and the given one. Now, you might say, well, wait, don't we know a new value? Now, couldn't I go from f of 5 and use f of -6? And the answer is sure, but I would suggest 2 reasons maybe not to do that for this problem. Reason number 1 is to go from -6 over to 5 is more area to add up. And reason number 2 is, what if you got this area wrong? And if you use that wrong area within the same problem, there's always a chance they might not give you those points. So I would suggest just stick with the ones that they gave you and go from there. So I'm going to work with an x value of -2 and an x value of 5. So we'll go the integral from -2 to 5 of f prime of x dx. And I apologize for the small writing. That's going to give us, through the fundamental theorem of calculus, f of 5 minus f of -2. Manipulating this, we are interested in f of 5, so that's going to be f of -2 added over there. So we get f of -2 plus the integral -2 to 5, f prime of x dx, and that is equal to f of 5. Filling this in, f of -2 is, of course, 7. Then we need to sum up the area from -2, and I'm going to erase this just so we don't get confused by it. However, I will outline this in red just so we don't forget that this area here, half of 8, this is an area of 4. Okay, and now we're going to have to sum up the area as we move to the right, and I'll do 2 shapes and we'll outline them in colors just so we can keep everything set that way. There's one shape and here is another. Okay, in blue we have, and I'll do the math down here, this is half of a circle, so it's half of pi r squared, and the radius you should be able to see is 2. Not terrible, right? And so that's 4. Half of 4 is 2, so that's going to give us 2 pi. So my area in here is 2 pi. And then we also have our friendly triangle down here, 1/2. The base is 1, 2, 3, and the height looks to be 2. Okay, half of 6 is 3. So this is an area of 3. Awesome. All right, so how does this work? Well, we are going to sum up the area here to find a value for f of 5. There are 2 areas, the one in blue, which is 2 pi, and the one in green, which is 3. Did you catch my mistake? The mistake, of course, is that the blue area is below the x-axis, which means that needs to be negative area. And then we combine like terms. I'm going to write the f of 5 over here. We have 7 plus 3, which is 10 minus 2 pi. Don't make the mistake that I see some students do where they say, oh, pi is approximately 3.14, and then they multiply that out and then combine it with 10. Especially because these are going to be no calculator problems. You need to leave it as exact as possible, and the symbol pi is the most exact way to display pi. As soon as you round it, you lose that exactness. So there we go. We have these two guys, and we've done the hard part. Okay, part B. On what intervals is f increasing? Okay, well, I think in order to find increasing, decreasing, we know we need to first look at where f prime of x is equal to 0, or where f prime of x does not exist. So one of the reasons we're going through this is to review your knowledge from last semester. We want to try to do everything we did last semester, each unit this semester, so it stays fresh. So what are we doing here? We're finding critical points. Okay. Well, f prime of x does not exist would mean if you look at the graph of f prime, which is this whole graph over here, right, there would be a gap. It would literally be a point that did not exist, an open circle, and there are no open circles here. So f prime does not exist, or f prime exists everywhere. Right? You might say, but there's sharp points here, and you're right, there are sharp points there, which means f double prime doesn't exist at those points. The derivative of the graph doesn't exist at sharp points, but this f prime graph exists everywhere. However, where does f prime of x equal 0? Well, I think we can see these 3 points along the interval. We get -2, 2, and then 3, 4, 5. You could certainly exclude 5 because 5 is an endpoint and critical points are not endpoints. So we have that. What's the next step after you find your critical points? Well, yeah, you just make a quick sign chart. So sign chart wise, let's go ahead, and that's a huge sign chart. We'll use the base of this box to help us out. We want to look at the signs of f prime of x to tell things about f. We are looking on the interval from -6 to 5. There are really 2 zeros in here. There are none of those DNEs. How do we find the signs of f prime? Well, we just look at the location of f prime. The sign of f prime is positive first because the f prime is above the x-axis. F prime has positive y values, positive outputs. Then we're below the x-axis, and then we're above at the end. And so we can see that the original graph of f, which we'll think about in yellow, increases, and then decreases, and then increases. So on what intervals is f increasing? Well, we would say something like f is increasing on -6 to -2 and 2 to 5 because, how do we justify? We state what's in the sign chart. Because f prime is positive, right? Literally just writing what's in the sign chart on those intervals. Easy. Last but not least, part C. Find the absolute minimum value. Oof. This one could be a little bit trickier. Now, the nice part is we already have a sign chart, so that's going to give us some initial analysis here, right? Looking at my sign chart, I can tell that f of x, which I did in yellow, is going to have a potential absolute max at these two pieces. Those are the highest points on my sign chart. And then a potential absolute min on these two. Now, that's a bit of an issue because we don't know which one in particular, and there's more than one critical point, and it really just gets obnoxious when there's more than one critical point. Some students will say, well, I can convince the grader that we don't need to try -2 and 5, and you can tell the reader that -2 is an absolute max because f prime changes from positive to negative, and you can tell them that 5 cannot be the absolute minimum because f increases from 2 to the end of the interval. Great, but now you've just written 2 to 3 sentences that take up a ton of space. In the time that you did that, I'm pretty sure you could have just found 2 areas to be fully convincing to the reader. And by finding those areas, what do I mean? Well, I mean we're doing, of course, our candidates test. We're going to take the 4 possible candidates. All of these are possible, the endpoints and the critical points, and we're going to see the actual values of f. So we're going to take our candidates. We have x. We're going to look at the outputs on f of x. 1, 2, 3, 4 of them. negative 6, negative 2, 2, and 5. And now we need to find the outputs. But you're like, how do we find the outputs? We don't have an equation. That's true, but notice how they set you up here. They already had you find two outputs, didn't they? From negative 6 and f of 5. F of negative 6 was 3, and f of 5 was 10 minus 2 pi. Okay, and they gave you one. F of negative 2 is 7. That's exciting as well. So really, we only need to find one value, and that's important because that one value is definitely a potential candidate for an absolute min, right? It's either going to be here or here. So we just have to find one value. How do we do it? Well, we do it the exact same way that we did everything else up here. Since positive 2 is to the right of negative 2, I'm probably going to base it off this interval. And in fact, I can probably just do the same thing as here. Can you memorize that quickly? Where instead of f of 5, I'm going to say f of 2. So f of 2 is going to be found by doing f of negative 2 plus the integral from negative 2 to 2 of f prime of x dx. And if that's tricky for you, just go back to exactly what we did up here. Go from negative 2 to 2, manipulate the fundamental theorem, and you'll get what we found down here. Okay, working this out, we know that negative 2 is 7, right? That was given to us. And then what is this area from negative 2 to 2 on the graph? Oh, it's just 2 pi. All right, so 7 plus 2 pi, and I think that's it. 7 plus 2 pi. Lovely. Now, I'm a little concerned that I made a mistake here. Oh, I did. I forgot that that area was negative, didn't I? So it's 7 minus 2 pi. And the reason I knew I was wrong is because I'm like, 7 plus 2 pi. Well, 2 times approximately 3, and then 7 plus that is going to be 13. And I'm like, 13 is way bigger than this guy, whatever that is, but it shouldn't be because this should be smaller than the one up here. So I'm like, oh, that's not right. So that's how I figured out that negative needed to go there. Okay, so then we have to ask the question of which one is the smallest value. Well, I know that these two are not the smallest, just based on the sign chart, or you can just do some quick mental math. 10 minus approximately 6 is 4. Don't cross out your answers, though, because if you cross these out, the AP readers can't read them, and they have to pretend that they're not there, and so you wouldn't get credit for doing the full candidates test. However, we do have to decide which one of these two is the smallest. Again, though, just estimate a little bit. 7 minus 2 times 3-ish. 7 minus 6 is 1. This one has to be our absolute minimum. Okay. If you want to write a sentence about this, you can. Sometimes you can get away with circling it. I would say something like the absolute minimum occurs at x equals 2 and has a value of 7 minus 2 pi. Okay. Just a quick sentence is not a bad thing at all. And then you're good. There, it says justify your answer. This is the justification. Correctly using your candidates test is your justification. All right, so there's our first of two examples. The second example I wanted to show you in a different form, but really it's the same thing. But I wanted to make sure you were comfortable with a few other things here. So let's take a look at 2014 question 3. And I changed one part of it, but we'll talk about it when we get there. So we have the function f over here, and you might remember me saying they're never going to give you f. They're always going to give you the derivative. And so you're like, wait, is Mr. Grant lying to us? Because it says they gave us the graph of f. Well, they did, but they're very clever about this because they're telling us that g of x is now the antiderivative of f. So if g of x is the antiderivative, right, we would say that g of x, you could, and this isn't quite right, so I would not write this part. G of x is capital F. And so if this graph is lowercase f, isn't this graph the derivative of g of x? And so this is just a fancy way that they might give you the graph of the derivative, just disguised. Okay, we know it consists of 3 line segments. You're like, phew, no circles, no pies, very exciting. And they ask us to find g of 3. All right, well, this is actually a little easier because we have x here. So g of 3 just means replace our x with 3, and we get f of t dt. We are going from negative 3 over to 1, 2, 3. wherever that guy is, I see two triangles here. I see one triangle that I'm outlining in blue, and I see another triangle that I'm outlining in purple, right? We're always looking for that area between the graph and the x-axis. So the blue triangle, I think, won't be too terrible. Our blue triangle is above the x-axis, so it's positive, 1/2, has a nice easy base. This is 1, 2, 3, 4, 5, a base of 5. And then the height, we can just count on the y-axis, 1, 2, 3, 4. Height of 4. Awesome. Then we have to take away the purple triangle, which is below the x-axis. Now the issue here is you might look at this and go, wait, where is that point? And there are a few ways to do this. I'm not necessarily even sure what the fastest way is. I would probably have found the slope between these two. You could count the slope right here. Right? You say, okay, well, here's this point, here's this point. We have to go down 1, 2, 3, 4, and then over 2, and that would get you to 4. But if you only wanted to go half the distance, right, because of 3, you have to cut your slope in half. You would have to go down 2 and over 1. Slopes are just a whole bunch of similar triangles, and so you should be able to see this as the point 3, -2. The other way you could do it is you could write the equation of this line. I'll do this whole line in yellow right here. You could say, well, it's an easy equation to write. Y equals mx plus b. We just said the slope is down 4 over 2 or down 2 over 1, so the slope is -2. And then the y-intercept is 4. And so if you wanted to find what the output is down here, you would just take 3, substitute in. That's -6 plus 4, which is -2. Either way, though, I'm pretty convinced that this small triangle, we'll go back and do it in purple again, right here, is going to have a height of 2 and a base of 1. I mentioned this before, but I would suggest that you don't say that this 2 is -2. I much prefer just doing all the math regularly and then realizing that because this triangle is below the x-axis, there's a negative. Otherwise, I see some students end up putting 2 negative signs and things get confusing. So I see 1/2, a base of 1, and a height of 2. Okay. So cleaning this up, and there's nothing too much we have to do here. I think 4 times 5 is 20, half of 20 is 10, and then half of 2 is 1, 10 minus 1 is 9. Great. Just some basic areas. We covered this last unit pretty thoroughly, so that's all nice and fun. Now let's look at part B, because this is where things can start being a little tricky. On what open intervals contained in blah, 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 is the graph of G both increasing and concave down? Give a reason for your answer. Okay, well, I definitely know if we're increasing and concave down that I'm going to need a double sign chart here. Don't know how big yet, but I'm just going to use that lower corner, get some straight lines. Okay, and I know we need to look at G prime to see where G is increasing, and we need to look at G double prime to see where G is concave down. We're looking from -5 to 4, and this gives us a good understanding of where we need to go next. If we're going to look at G prime and G double prime, then we need to find those equations. To find those equations, let's start with the equation for G of x. Leave yourself a little bit of room on each side, right? G of x was the integral from -3 to x of f of t dt, right? They gave us that at the beginning. We want G prime, so we should probably take the derivative of each side. Okay. The derivative of G of x is G prime of x. The derivative of an integral, this is the fundamental theorem, we call it part 2, where they kind of cancel out and the x gets substituted in. And then technically you multiply by the derivative of what you substituted in, but derivative of x is just 1, so no reason to do anything extra there. That's G prime, but what if you wanted G double prime? Well, G double prime I think isn't too terrible. You just take the derivative of each side again, and now we're there. All right, so how do we find our points on here? I always think it's important to show this next step. So I would say, well, to find our important points on G prime, these are called critical points, we want to determine where G prime of x equals 0. But since G prime is the same as f of x, we need to find where f of x equals 0. And finding where a graph equals 0 is pretty easy because it's just a graph and you just look for the zeros. And I see -3 and 2, right? So we know that x is going to be -3 and 2 down here. So we have -5, -4, here's -3, and then also 2. We should also look to see where g prime is undefined, but I know by looking at this graph there's no gaps, there's no open circles. G prime or f of x exists everywhere. All right, the other thing we need to look at is where is g double prime of x equal to 0? That's where f prime of x equals 0. And so where does the slope of this graph, and I'm going to erase this, where does the slope equal 0? I actually don't see anywhere the slope equals 0. But you might say, well, wait, if we're looking for f prime, what do we remember about these weird sharp points, these pointy points over here? Well, those don't have a slope of 0. F prime is not 0 there. What do you remember? Oh yeah, f is not differentiable, which means f prime does not exist there. So there are no solutions for this one. However, g prime of x does not exist, means f prime of x does not exist, and the derivative of that graph does not exist at each of those sharp points, -3 and 0. Okay, so -3 again, we have a little does not exist, and 0. Okay, now we can go ahead and keep things like this. However, I'm kind of fond of putting little dashed lines through just so we can see that there's really going to be 4 different kind of compartments here, and then we can talk about the signs as we go through. So to determine the signs of g prime, we look at the signs of f. So it looks to me like f is positive, 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 negative, right? So as we look at this, f was from -5 to -3, positive, 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 negative. Great. Okay, what happens next? Well, g double prime is f prime, so what are the slopes? F is decreasing, so the slope is negative, then positive, and then negative all the way down. So we have negative, positive, then negative all the way down. From here, we're looking for both increasing and concave down. So here are my 3 increasings. Here are my concave downs, and so we can see the overlap occurs on these 2 intervals, and so now we conclude. Give a reason for your answer. Alrighty. I'm going to be probably overly wordy here just because I don't want to miss anything, but let's begin. We're going to say the graph of G is both increasing and concave down on, let's give those open intervals. They said open, so there's no reason to include them, -5 to -3 and 0 to 2, because, and then since we've already established this relationship up here, you can state that again if you'd like, and that's never a bad thing. However, I'm just going to probably skim over that, and I'm going to just work with f. And I'm going to say because f of x is positive. Now, which one of those does that take care of? I think f being positive takes care of g prime, right? That positive piece is what we needed down here, and we can see that from the graph up above. And now I'm not going to reference f prime. Why am I not going to talk about f prime? We don't have the graph of f prime up here. And whatever we reference, we need to reference what is given to us in the problem. Now, if you create a new equation, cool. We created new equations here, but we still don't want to talk about f prime because we don't have the graph of f prime. So instead of saying that f prime is negative, how do we phrase that for f of x? Well, how did we know f prime is negative here? Oh, it's because f of x was decreasing. And so the second part I'm going to say because f of x is positive and f of x is decreasing on those intervals. Now, if you wanted to go further and be more wordy, you could say because f of x is positive, which means that g prime is positive, and f of x is decreasing, which means g double prime is negative. You could go further if you wanted, but really they're going to be looking for the connection of f of x. As long as you have these 2 equations, you should be fine. Last but not least, find the absolute minimum value of g of x. Okay, well, just to remind you, g of x, yeah, that should be fine. G of x was given as that equation, -3 to x, f of t dt. Whenever you find absolute minimums or maximums, the first step you do is you take the derivative and find the critical points. But we did that earlier. We took the derivative and found the critical points. Then it becomes the candidates test. So our candidates test, we have x and g of x. What are our candidates? Well, we need the endpoints first. Those are -5 and 4. -5 and 4. And then we need any critical points. And we found 2 critical points from before. That's -3 and 2. All right. Now, looking at this, we need to go through and find a bunch of areas, but I think it shouldn't be as bad as you're expecting. G of -3 is very easy. -3 substituted in there. -3 to -3 is 0. Nice. Okay. We also should probably take a look back at our original graph. We know our graph is going to increase until here and then decrease at the end. I'm pretty darn confident then that G is going to have an absolute max at 2, right? But let's maybe see if we can understand why that's the case as we go through and find the areas. So let's just do each one, right? -5 first. So if I want to find, we'll do these in different colors, if I want to find G of -5, that is just from -3 to -5, f of t dt. Maybe you'll realize that this order is, we'll call it backwards. It works, but it's better if we flip it and go from least to greatest every time. So we have the negative that's hanging out here. -5 to -3 on this graph up above. -5 to -3 is just this triangle. This is a 2 by 2. So it becomes 1/2 by 2 by 2. Half of 4 is 2, so we get -2. G of -5, -2. What about +2? Well, this one we'll do in blue, so G of 2 is the integral from -3 to 2, f of t dt. Looking up here, +2 and -3, that's just the triangle we found earlier, luckily and coincidentally in blue again. That one's just going to be 10. And it's looking pretty good so far because we said the absolute max is at 2 and it's a pretty large value, but then let's double check 4. Well, I'm again pretty certain that's not going to be it because we're increasing the value from -3 every time. So look what happens. We get more area, more area, more area, keep adding on area, adding on area, adding on area. But then what happens from 2 to 4? Oh yeah, we lose area, lose area, lose area, and so we're going to get smaller in area. How much smaller? Well, we can do this new triangle over here, but it's nothing bad, I don't think. This new triangle that I meant to do in yellow has a base of 2 and a height of 4. 2 times 4, half of that is going to give us 4. So how do we show this? Well, let's do it in, we already started with yellow. So G of 4 is the integral from -3 to 4, f of t dt. Okay? And you would probably treat this as 2 different areas, and if you wanted, you could write it as this integral minus the one at the end. Let's just know that the area from -3 to 2 is 10, and then we have to subtract off the area at the very end, which we said is 4. And so we end up with an area of 6. Great. How do we finish? Well, I again always like to write a quick sentence. It's not bad. So we'd say the absolute min occurs at x equals 2 and has a value of 10. And by min, I actually meant max, and so that's really funny. I was going through and finding the absolute max this entire time when really they asked for the absolute min. So I'm not going to change too much here. The absolute max is here. That's exciting. What about the absolute min? Well, the absolute min is clearly going to be the smallest one. Alrighty then, and I imagine you can write that sentence, right? Occurs at x equals -5, has a value of -2. Oh well. Either way, you needed the candidates test and maybe some basic reading. One of those skills I lacked, but I made up for it at the end. Great. That's it for today. Of course, you guys have some practice. So what I've done down below is given you 1, 2, 3, 4, 5 free response questions. Now remember, for each free response question, you are given 15 minutes on the AP exam. And although you can take a little bit more, then it eats into your other free response questions, right? There's 6 free responses, 15 minutes per each one. So technically, 5 times 15, 75 minutes, that could be definitely a decent chunk of your time. So what I've done instead is I've bolded various parts of each free response because remember, most free responses don't link up with each other with regards to each piece. So if you don't know how to do A, you can still do D, and so on and so forth. So what I've asked you to do on each of them is one or two of these bolded parts. So whenever you see a bolded part right here, those are the ones that I would like you to try, please. This one has 2, right, and this last one only has 1. So but if you put those bolded parts together, that's maybe the equivalent maybe of 2 free responses, so 30 total minutes. Hopefully it'll even be less than that. I am suggesting that because you're going to have just about a week or so to do this before I start checking, that you will have some other free responses, I would suggest that you try to do each of the free responses. The more free responses you do that are released, the better you're going to be at decoding and understanding what these free responses are asking. And I think I do a pretty good job of giving you the different themes of those, right? We did particle motion last time. We're doing extrema this time. We're going to do some good tabular data next time. And so at the end, before the AP exam, we're going to repeat these themes. And the more that you've seen them now, the better you're going to be at identifying and working through those themes right before and on the AP exam. So should you do all of these? Yes. Do you have to? No, you do have to do the bolded ones. But I think you'll find by the time you do the bolded one, the other 2 parts will go much faster. So thank you for hanging out with me today, and I'm excited to have you guys back next class.